Welcome back, guys. Today on this video we are going to see some divisibility tests, whether a number is divisible by a number or not, right? So let's check it out. You'll know what I'm talking about. But before that, I want to clear out something. Like, we have to know the place value. I mean, like, if there is a number, say 1 2 3 4. Oops, 4. So this one, the last digit, we call it ones place, and this one tens place, and this one hundred place, and this one thousand place, thousand place. Okay, remember it. This one is ones place, this one is tens place, this one is hundred place, this one is thousand place. Ones place, there is a single digit. In tens place, there will be x, and say there will be another zero, another digit after it. In hundreds place, it will be like x 0 0. All right. So in 100 we have two zeros. In 10 we have 10. Remember it like that. So this one is ones place, this one is tens place, this one is hundred place, this one thousand, and so on. All right. Keep this in mind. So actually this divisibility test is about whether a number x is divisible by say 10 or not, or 5 or not. We have to check the divisibility of each number. The three first three divisibility tests will be quite easy, like divisibility by 10, divisibility by 5, divisibility by 2. It is to make familiar with the topic. Alright. So if I say how do you check whether a number is divisible by 10 or not? How will you check? Don't see over here the definition. I mean, pause for a minute and think. It's very simple. You all know it, right? If a number is divisible by 10, then the ones place means the last digit will be 0. If it's not 0, then it's not divisible by 10. Before that, any number can come. I mean, 1 2 3, any here x y z can come. I mean, x value can be anything, y value can be anything, z value can be anything, but here we need to have 0. So if a number has 0 in the ones place, then it is divisible by 10. Example, 100, 10, or 0 itself, something like that, right? 230, it is still divisible by 10. It was easy, so let's move on. Divisibility by 5, let's do it quick. Divisibility by 5, we know that 5, if we multiply it, 5 2 the 10, 5 3 the 15, 5 4 the, these are the multiples, 20 25 30 35. So these are the multiples, right? And so on. We have a, if we see the pattern, that on the ones place we have 5 0 5 0 5 0. So we know that the multiples of 5, I mean these numbers, are divisible by 5, right? Since it is a multiple of 5, it's divisible by 5. So, and these multiples are ending with 0 or 5. So we know that on the ones place we need to have 0 and 5. So here is the definition. If a number which has either 0 or 5 in its one place, divisible by 5. It was very easy. Let's move on. Divisibility by 2 is also very easy, because it needs to have even number in ones place. A number is divisible by 2 if it has any of the digits 0 2 4 6 or 8 in its ones place. Right, let's move on. Now, divisibility by 3. Don't look at the definition. I'll try to explain with an example. How do we check the divisibility of 3? If, say, there's a number x, y, z, and this is divisible by 3, only when, divisible by 3, there is no remainder. So if it is x, y, z, this number is divisible by 3, then x plus y plus z, if we sum them and the result, say another number, is divisible by 3, then it's divisible by 3, then xyz is divisible by 3. It's a little bit confusing. I'll clear it out. Say there is a number 2, 7, and 6, 276. If I ask you directly that 276, is it divisible by 3? Is it divisible by 3? You would be like calculating, right? You will be calculating in mind something like this. I'll first divide it like this in your mind, and 6 to, oh, it's divisible. You'll check it like that. But a shortcut way is to just sum it up. Like here I said, sum it up. How much is it? 9. This one is 9. 9 plus 6, 15. We know that 15 is divisible by 3, because 15, 3 5s are 3 into 5 is 15. So 15 is divisible. Hence, this result is divisible. This one is divisible. So if I give you a very large number, x, y, z, a, b, c, something like that, 1, 2, 3, 4, 5, is it divisible by 3 or not? You don't need to divide it, just sum it up. 1 plus 2 plus 3 plus 4 plus 5. We know that 5 plus 1, sorry, what I'm doing, 5 plus 4, 9, 9 plus 3, 12, 14, 15. So this number is also divisible by 3, because the sum is 15, and we know that 15 is divisible by 3. It was quite easy. Divisibility by 6. How do we know that whether a number is divisible by 6 or not? If a number is divisible by 2 and 3 both, then it is divisible by 6 also. Remember it. A number is given, say again 27. We need to check whether it's divisible by 6 or not. We know that it's divisible by 3, but it's not divisible by 2, right? So it's not divisible by 6. We need to have the number x divisible by 2 and divisible by 3, both of them. We need the x number to be divisible by 2 and 3 both. Only then it will be divisible by 6. Let's take an example. 18. 18 is divisible by 2, right? 2 9s are 18, right? And what about, 18, the same number. Is it divisible by 3? Yeah. 6, yeah. So we know that 18 is divisible by 2, 18 is divisible by 3. So 18 will be divisible by 6. That's very easy. I don't know why I've given it 2 times. Just skip it over. A number with this one, divisibility by 4. This thing will come in very handy if you need to, if the question is asked like a huge number is given and you need to check whether it's divisible by 4 or not. So if there's a long number given, 2, 5, 9, 4, 3, 7 2. Say we don't know that is it divisible, or maybe longer than this, right? It may be given in test. We need to check whether it's divisible by 4 or not. How to do it? The definition is saying a number with 3 or more digits. 3 or more digits. 1 2 3 4 5 6 7. In our example we have 7-digit number, right, which is more than 3 or more. Either it has to be 3 or more, right? It's 7-digit. It's divisible by 4 if the number formed by the last 2 digits, that is this one, is divisible by 4. I mean, this number is given. We don't need to divide the whole thing. We just need to look at the last 2 number, that is 72. We need to see whether this 72 is divisible by 4 or not. So 3 2 8 4 is 32. So this 72 is divisible by 4. So I know that by this logic I know that this whole number is divisible by 4. If let's just check it out for surety. You might be having doubt, I don't know, but let's just check it out. If you didn't know this logic, then we would be doing this right, but let's do it. We know that this is divisible by 4, but still let's do it. 6 4s are 24. 1 9, I'll do it very fast. 4 is 16, so 3 is remaining, so 4 comes down. 8 4 is 32, so 2, then 3 comes down, then 5 is 20, then 3, then 7 comes down, right? 9 is 36. 1 and 2 comes down, so at last we have here 3 12, right? So it's divisible by 4. You saw it, the remainder is 0. So if you know this technique, if you know this method, you don't need to do the whole thing. You just need to check the last 2 number for the divisibility by 4. What about divisibility by 8? It's similar to 4. It's just that, let's take this example again, 2 5 whatever it was, 9 4 3 7 2. It's quite similar to this one. In this, what we have to do is we need to check the last 3 digits. Instead of last 2 digits, we need to check the last 3 digits. So a number with 4 or more digits, it is 7-digit number. It is 4 or more digits. It's more than 4, right? It's divisible by 8 if the number formed by the last 3 is divisible by 8. So we just need to check the last 3 digits, whether it's divisible by 8 or not. So 32 and 552, and we know that it's 6 48 4. So remainder is there 4. So this total number is not divisible by 8. It's not divisible by 8, right? So remember, for divisibility by 8, just take the last 3 digits and divide it. Divisibility by 9, it's similar to divisibility by 3. In 3, if you remember, we sum it up, right? We sum up the digit. So if we want to check the divisibility by 9, then let's take a number which is divisible by 9. Actually, I'm going to take it for 608. It's in the example. So if I take this number, we don't know whether it's divisible by 9 or not, but let's do it by the definition. If the sum of the digits of a number is divisible by 9, sum of the digits is divisible. Sum of the digits, right, is divisible by 9, then the number itself, this number itself, will be divisible by 9. So what it says is, if the sum of the digits, sum of these and these, so 4 plus 6 plus 0 plus 8, if the sum of these number, answer will be 10 and 18. 18. So if the 18 is divisible by 9, which we know that it is divisible, 2 2 right? So it's divisible by 9, the 18 is divisible by 9. We know that this number will be divisible by 9 because the sum of the digit is divisible by 9, so the number itself will be divisible by 9. But let's just check it out. 9 5s 45, 9 1s 9, 9 2s 18, 18. So it's divisible. So for 9 it's similar to 3, like we need to sum up the digit and check whether the result is divisible by 9 or not. If it is, then the whole thing is divisible by 9. The last one, it's quite long video, sorry for that, but just don't worry about this big thing, right? Let's take an example and clear it out. Say 61809. It's also in the example. We need to know that whether this number is divisible by 9 or not. Okay, so what we need to do is sum these number and sum these number, I mean add these number. So 9 8 plus 8 plus 6, 9 plus 8 plus 6 will be how much? 15 and 23, 23, right? And 0 plus 1 will be, sorry, this is 0 1. We have these two and we need to find the difference of these two. So 23 minus 1 will be 22. Is this number divisible by 11? Yeah, it's divisible. It's 2 jana. So this whole thing will be divisible by 11. That's the logic. I'll clear it out. If I say there is x, y, z, a, b, c, d, e, right? We need to know whether this number is divisible by 11 or not. What we need to do is sum this thing up and sum this up, right? The up one, and sum it up, and the down one, sum it up and do the difference. I mean minus it, do the difference from bigger one, right? And if the difference is divisible by 11, or if the difference is 0, remember it, if the difference is 0 or if it is divisible by 11, then the whole thing is divisible by 11. That's the complete thing given here. If you want to read over the definition, you can go over it. Thank you for watching. Goodbye.